So hi everyone, I'm Raghav, and in this video we will discuss all the problems of the Codechef contest except the last problem of Div 1 contest. Okay, so this is the very first problem for the Div 4. Div 4. The problem is sweets shop. The problem says that Sushil. Okay, just one second. Yeah. So the problem says Sushil went to a sweet shop because he always craves to eat sweets. This is not good for his health. Basically, some story. The problem says that he has X rupees. Sushil is having X rupees. A laddu costs rupees 10 and a jalebi costs rupees 20. And uh, Sushil has bought in laddus. So how many jalebis can he buy with the remaining money? That is the problem. Basically, there is someone with name Sushil. Uh, there are two things: laddu, which costs rupees 10, and there is something jalebi, which costs 20 rupees. And he had X rupees. He has already bought in laddu, so it means that he has spent 10 into an rupees. And now this is the remaining number of, or basically the remaining money he has. Now, from this remaining money, how many jalebi can this guy buy? This is the question. And the answer is pretty simple. You can just say the remaining amount he has divided by the cost of jalebi, that is 20. This would be the number of jalebis this guy can buy. A pretty straightforward problem. And yeah, that's it. So we can just code it like this. There were uh, X rupees initially and N number of laddus have been bought. So X minus 10 into N, that is the remaining amount. If you divide it by 20, that is the number of jalebi this guy can buy. And that's it. So this was a simple problem. Is it clear? Or does anybody have any doubt? If you have any doubt, then please ask in chat. Otherwise, we can move on to the next problem. Okay, nice. So let's move on to the next problem. The second problem is long queue. Long queue. The problem says uh, that unfortunately, as soon as Sushil reached the sweet shop, he saw there was a huge queue. At first, Sushil saw giants at the end of the line, but he's impatient and now he decided to bully people in front of him by flexing his wealth so that they will let him pass. There are n people on the line with ith person having wealth of rupees AI. Sushil currently is the nth person in this line. And so the problem is like this. Uh, just one second. There is a queue in front of that sweets shop. There are people in this queue. And Sushil is the last guy right now. The ith person has AI amount of rupees. And Sushil, who is the last guy, but he's impatient. So he decided that he will bully the people who are just in front of him. So if Sushil is right at this place, this is the front of the queue right now, and this is the back. Sushil is right at the back. So he will try to bully the person who is just next to him. And they have told us that he can bully the person right in front of him if that person has less than or equal to half of his total money. So it is like if Sushil is having an amount of money and the person right next to him is having a n minus 1 amount of money, and if this amount of money which this guy has is less than or equal to an by 2, in this case, Sushil can bully this guy. And what will happen next is Sushi will come at this place and the guy who was right next to him will come at this place. they will basically swap their positions. And then Sushil will again try to bully the person who's next, right next to him, as soon as he can do it. And let's say Sushil pushed his way till this position, and now he is talking with this guy who is, let's say, having A3 amount of money. And now in this case, if this A3 amount of money which that guy had was greater than the amount of money which Sushil had, basically greater than the half of the amount of money which Sushil had, then Sushil cannot bully this guy, and Sushil will have to end up at this position. Um, and the problem is just asking us that if Sushil had the wealth, okay, sorry, we have to find the final position of Sushil. So if Sushil had X amount of money, then he can bully all the people having less than or equal to X by 2 amount of money. Now in this case, since Sushil would have failed to bully this guy and would have ended up at this place, this is one, two, three, and fourth position. So the answer would have been 4. Let us take one example. If the problem is like this, maybe like this, where the queue is 210 210 48. If the given queue was having 210 48, these are the wealths or the money of the people in the queue, and Sushil is currently this guy. He will look at the front of him. He saw that, hey, I'm having more than double of the money which this guy has, so I can bully him. And they will swap their positions, and the new positions will become 2 10 8 4, right? And our Sushil guy is at this place now. Now he will try to bully the person who is right next to him, but since the person right next to him is having more than 4 amount of money, because 4 is the half of 8, since he is having 8 more than 8 by 2 amount of money, Sushil cannot bully this guy, and he will have to end up at this place itself, which is the position 3. 1 2 and 3, right? So our answer in this case will also be equal to 3. So does anybody have any doubt till this point in the problem? Okay, if nobody has any doubt, then let's proceed with the logic. The logic is pretty simple for this problem if you understood the problem statement completely. We were being given an array representing the wealths of all the people. So AN is the amount of money which Sushil has, right? So to figure out the final position of Sushil, what we can do is we can try to look at, like compare his wealth with the guy at the position n minus 1, then with the guy at the position n minus 2, then with the guy at the position n minus 3, and so on. At some place, if that uh, guy, let's say at position I, is having money more than a n by 2, in that case, we will know that, hey, Sushil cannot come at the ith position. So the answer must be I plus 1. Does it make sense? Guys, yes or no? Does it make sense? We can just iterate this array from right to left, and as soon as we reach this position, we can just say that our answer is I plus 1. Right. Now, while implementing this logic, if you are using a language like C++ or any other programming language which has zero-based indexing, in that case, um, like in the problem statement, they were having the wealths from A1 till AN, but in your code, in your array, you will have values from A0 till A of n minus 1. So you have to remember this thing in your mind, that whatever index you are talking for your array, your answer would should like if let's say you got the you got some answer in this zero based indexing, then the final answer which you will have to print should be answer plus one, because we have to give our answer in one based indexing. I will take up an example to make it completely clear. Let's consider this example itself. 21048, 21048. So initially Sushil was at this place. है ना? What will be the indices right now? According to the problem statement, these indices should be 1, 2, 3, 4. But in our code, the indices will be 0, 1, 2, 3, because we use zero based indexing. After that, um, like in this problem, we will start our for loop from this place, that is the last second guy, and we'll go towards the left. In this case, this AI is less than equal to A of n minus 1 by 2. So we will be able to come at this place, right? Then we will compare uh, the amount of money which Sushil has with this guy. I'm just showing you a dry run, because this is the second problem of the contest. So I'm expecting that a beginner of 1 star or 2 star coder would be watching this explanation. So this is why I'm going a bit slow, just in case if somebody feels that why are we going so slow. So uh, now when uh, we will compare Sushil's money with this guy, you will see that this AI, which is nothing but this A1, this A1 is actually greater than, or you can say that for I equal to 1, this AI thing is greater than A of n minus 1 by 2, right? So we will just say that our answer should be equal to I plus 1, right? Our answer should here be equal to 2. And in the final answer, we have to give the answer for one based indexing. So in our zero based indexing, we got answer equal to 2. We will have to print answer plus 1, so that it will become compatible with the answer uh, which we could have got in one based indexing. So does it make sense that why are we printing answer plus 1 here at the end, to convert our answer from zero based indexing to one based indexing? So yes or no, guys? Does anybody feel it confusing? If you feel it confusing, then feel free to ask. Okay, if it is clear, then let's go to the code part. In my case, I took all the inputs. Then initially, I initialized my answer. Let me change it a bit so that it looks like the. Okay, let me just change it a bit so that it looks like the explanation. If AI is greater than if minus 1 by 2, then answer equal to y plus 1 and break. And we will print answer plus 1. So as per our explanation, we will go from the last second guy, that is having the index n minus 2 in our explanation, like in our zero based indexing. And as soon as we find a guy who is having more than half of the money which Sushil had, then we will say answer equal to I plus 1, right? We will say answer equal to I plus 1. And at the end of the day, since our answer here is in zero based indexing, but we have to print the answer for one based indexing, that is why we will add 1 to the final answer. So if it is clear, then let's move on to the next problem. The third problem. This problem says that Sushil has an array A of integers n integers. Let me just explain it here. Sushil is having an array of length n. Let's say we have 2, 3, 1, 4. And Sushil will create a prefix sum array from this. If you have never heard about prefix sum array, then uh, let me give you a little bit of explanation of what we do in it. In a prefix sum array, at the ith index, we store the sum of all the elements in the original array from index 0 till index I. So if you talk about prefix of maybe 2, then it would be nothing but A0 plus A1 plus A2. Fine. So Sushil will create a prefix sum array from the array he has, and we are being told that he hates the even numbers, but he likes odd numbers, and thus he wants to make sure. Uh, thus he wants to sure. Does it mean thus wants to sure there are? Okay, basically, he is willing to have as many odd numbers as possible in the prefix sum array P. So the original array was being named as A, and the prefix sum array which we are creating is named as P. And what we want is, like, for this array an, the prefix array will look like this. The prefix array will have size 4, basically equal to n, and the sum of the first element is 2, the sum of the first two elements is 5, the sum of the first three elements is 6, and the sum of all the first four elements is 10. So he will create a prefix sum array, and he wants to have the maximum possible number of odd elements. Like, basically, he wants as many odd elements as possible in the prefix sum array, as many odd numbers as possible. He is allowed to play with the array A and rearrange it arbitrarily. Find the maximum number of odd elements in the prefix sum array P if Sushil arranged them optimally. So Sushil is free to rearrange these elements before creating this prefix sum array. And what he wants to do is he wants to have as many odd elements as possible. Does it make sense? So since we will have to make sure that we are having as many odd elements as possible. Before that, let's recap one thing. If you sum two odd elements or two even elements, you will get even sum in both these cases. And if you have one odd element plus an even element, then you will have some odd. And if you have an even element plus odd element, again you will have odd sum, right? And in the prefix sum array, P of I is nothing but the sum of the first I elements, right? And P of I can actually be rewritten as P of I minus 1 plus AI, because this P of I minus 1 will actually have the sum of all the uh, elements from index 0 to I minus 1, right? So uh, we can use this information. If P of I minus 1 is odd, then we would really like to have this AI being even. If this P of I minus 1 was even, then we would have like to have it as odd, because we want to have odd elements, right? This was the main intuition. Now, since we can rearrange these elements in any way we like, now let's try to build an array from this 2314. Among these four elements, 2314, or basically among these four elements which we have 1, 2, 3, 4, which one would you like to pick up as the first one? I would say it makes sense to either think about 1 or 3 because both of these are odd. If you pick up an odd element as the first one, then P0 would be odd for sure, right? It will become odd for sure. So it makes sense to choose any one of them. It doesn't really matter which one you pick because we only care about even or odd, not really about their actual values. Nextly, um, let me draw the prefix sum array as well. So the elements which we can pick up now are 2, 3, 4. This is the array and this is the prefix sum array. So we have picked up one element. Now for the next element, which one should I pick among the 2, 3, 4 elements? Currently, the prefix sum till this part, basically this value, is odd. And we know that if we have an odd value, we would like to have an even value paired up with it so that we get another odd value, right? So it makes sense that maybe we should actually pick up 2 or 4, any one of them. We don't really have any problem even if we pick up 4 because we only care about even or odd, not the actual values. So if we have a 2 here, then the prefix sum array will have 3 at this position, the sum of the first two elements. Then for the next value, again, since we have an odd here, we would like to pick up an even number for this place, 1, 2, 4. Now these prefix sum array is looking like this. Now we don't really have any choice. We have only one element left, so let's place it. And this is the prefix sum array which we have created. It is having 1, 2, 3. It is having three odd numbers, right? So our score is gonna be equal to 3. And you can match it with the test case that it is 3. So it means that maybe the logic which we are having right now, the greedy idea which we are having right now, is making some sense, right? It might actually be good. So we can actually generalize this logic. What we did here is nothing but if we had any array of length n, the thing which we did is we just placed an odd number at the first place. Obviously, we can place it only if it exists. If we are being given an array having all the even elements and does not have any odd element, then the answer is obviously 0. But for the case, if you have at least one odd element, you will first of all place it only. After that, in the prefix sum array, you will have an odd element at the very first place. So you would like to have odd plus even so that it will have an odd element at this place after taking both of their sum. So you would place an even element here. You will again have an odd here. So again you will place an even. Again you will have an odd. And it will go on as long as you have some even elements. At some point, you would have placed all of your even elements and you would not have any even element to place. So till that point, you will have all of these as the odd elements. After that, since you only have the odd elements, obviously you will place all of them one by one. So what will happen is you will have an even coming up here, then an odd, then even, then odd, and so on, right? So guys, does it make sense of what will happen with the logic which we are having right now here? Does it make sense on how the pattern will look like? Yes or no? Okay, so in this Pn array, first of all, we had an odd element because we had placed an odd element in the original array. है ना? After that, we had many odd elements because we were placing even elements in the original array after rearrangements. Then, so first of all, we had one odd element. Then we had um, many odd elements, which was equal to the count of even elements. If we had 10 even elements in the array, then we would have placed this 10 times and we would have got 10 more odd elements in the prefix sum array. After that, we would have got even and then odd, then even, then odd, and so on. है ना? So in every two of these, we are getting one odd element. So basically, there will be uh, count of odd minus one number of elements here. So we will get count of odd minus 1 by 2 number of odd elements in this at this place. So the total number of odd elements we have got in the prefix sum array would be equal to this, right? First odd, then all evens, then remaining all odds. Yep, exactly. We are also doing the same. We first placed the odd element in the original array, then we placed all the even elements, and then we placed all the odd elements. How to get this kind of logic? For getting this logic, we just try to think greedily first. As in almost all the problems, you first of all just think about the intuition you get, which is generally greedy. So uh, you got this logic, and when you will get about this logic, you will try to think about it, you will try to generalize it, and it is actually making sense. And obviously, you would have verified your greedy idea with these test cases as well. Let's consider this as well. 3 4 7 2 3. So if you had the array as 3 4 7 2 3, then according to our logic, we will make it as one odd element first. So 3 coming up first, then all the even elements, that is 2 and 4, then all the odd elements, remaining odd elements, so 3 and 7. So for this array, the prefix sum array will look like 3 5 9 12 19. That is three odd elements coming up first, because we got one odd element, then two even elements, then two odd elements. So it should have been 1 plus 2 plus 2 by 2. And here as well, first we got one odd element, then we got two odd elements, then out of the next two we got one odd element, right? We got one odd element here. So the answer is coming up as 4. Now the next doubt you will have is, you should have this doubt, that I got an approach, it is working on the test cases, it is looking good, but what is the guarantee that this one is the best possible way of arranging these elements for getting the maximum number of odd elements? Basically, what is the guarantee that you cannot have a better possible arrangement? I know you will have this doubt. You should have this doubt. So the arrangement we have got is this one. Now for verifying whether there can be some better possible uh, arrangement or not, there can be multiple different ways for trying to prove it. But the one which I will discuss right now is that you have already got one solution now. You have already got uh, one way of arranging these elements. try to just make any change in it and see if there is any potential of getting a better answer. Basically, if you just try to pick up any of the even elements and place it um, between the odd elements or at the front or at any other place, is there a possibility of getting a better answer? Or you will or is there a guarantee that you will definitely get either a worse answer or the same answer? Similarly, try to think, if you place this odd element at some other place or any of these odd elements at any other place, can you get a better answer or not? If you see that you can never get a better answer, then there is a good chance that this might be the best possible answer, though it is not a concrete mathematical proof. But during contest, I think this is the best thing you can do, because it won't really take up a lot of time to uh, get confidence in your approach, and uh, the other mathematical proofs might take up a lot of time for you to just prove it, and you might not even be able to prove it. So in this case, as you can see, that if you try to place any other odd element at this place at the front, um, if you have two odd elements at the front, then in the prefixum array you will have an odd, then even, and then if you're placing some even elements in this normal array, then in the prefixum array you will have a lot of even elements. So if you just try to think about it, you will realize that it won't make sense to have even number of odd elements at the front. And if you brainstorm a little bit more, you will realize that if you place odd number of odd elements at the beginning and then all the even elements, then as well you will get the same answer, not a better one, but the same answer. And this is a good to do for you. Try to just think about different rearrangements and just analyze if you can get a better answer. You will realize that you cannot get a better answer, and uh, all the arrangements in which you are placing odd number of odd elements at the beginning, then all the even elements, and then all the remaining odd elements will have the same answer. And the safest thing to do is just place one odd element at the beginning, because in some problems you might have two odd numbers, so uh, or three odd numbers or four odd numbers or five odd numbers or one odd number or zero, है ना? So if you think of an approach that you will just place one odd number at the beginning and then even all the even elements and then all the remaining odd elements, then you will have only one edge case to consider where you have no odd numbers, right? So in our approach, what you can do is, first of all, calculate the number of, like basically find out the count of odd elements and the count of even elements. Then if this count of odd elements is equal to 0, then the answer is 0. If it is greater than 0, if the count of odd elements is greater than 0, then the answer is 1 plus count even plus count odd minus 1 by 2, as we had figured out just a little while ago. So guys, does it make sense? Are these things making sense? So in this problem, I actually did try to, first of all, recap the basics, which you must know. Um, Most probably everybody knows about this. It is just that people might not get it in their uh, thought process right away while thinking about the problem. It might take up a while to realize these observations. Then I did discuss about the intuitions which I had for getting an approach, the intuitive approach. And then I did talk about the proof of why this is going to be the best possible rearrangement and we cannot have any better rearrangement. Uh, Not exactly a concrete proof, but actually a good way of getting confidence in your approach. During the contest, you cannot prove your solution mathematically. Otherwise, you won't be able to you won't be able to solve a lot of problems. So guys, just please tell yes or no, or if you have any doubt, then please ask it. Should we move on to the code and solve the next problem later on, or do you have any doubts? No doubts. Okay, great. Yeah. So the code for this problem looks like this. First of all, I took all the inputs. Then I found the number of even and odd elements. And then the answer is just using the formula. And then I printed the answer. That's it. You can have a look at this. You can have a look at the code and we can move on. Yeah, I think we can move on now. So this is the fourth problem, I think, which says that given an array, we have to partition it into two distinct sets, S1 and S2. Okay. Okay. So the next problem says that we have been given an array. Let's call this array as A of n, having n elements. And we have to partition this array. Um, this array will have elements like A0, A1, A2. Maybe let's give them some random values. 3, 1, 2, 5. So 3, 1, 2, 5. We will have to partition this array into two parts. Along with this array, we would have been given some integer k, which is 1 in this case. We have to partition this array into two parts, having let's call these partitions as S1 and S2. In these partitions, they must have at least k elements, both of these partitions. And let's say we placed 3 and 1 together and 2 and 5 together. Then the score of this partitioning is actually equal to minimum of S1 plus maximum of S1 plus minimum of S2 plus maximum of S2. Right. This is what the problem says. Minimum, maximum, minimum, maximum for S1 and S2. In our case, minimum of S1 is 1, maximum is 3, minimum of S2 is 2, maximum is 5. The score here would be equal to 11. And this is not the best possible solution. The best possible solution has 14 as the maximum. So uh, I hope you got the logic. Sorry, I hope you got the problem. In the problem, we have to tell what is the maximum possible. We have to maximize the score. That's it. So one obvious observation here is whatever is the maximum element of the array, it doesn't matter in which set you put this. Either you put it in the first partition or the second partition, it will always remain the maximum even in its own partition, and it would always be it would always contribute to the score, right? It doesn't matter in which partition you put this. Similarly for the minimum guy, in whichever partition you put this, it will be the minimum even in that partition, and it will contribute to the score. So we know that the minimum guy will always contribute, maximum guy will always contribute. And it's quite obvious that since you want to maximize the score, you would not like to place this maximum guy and the second maximum guy together. You would not like to have a partition like 5 3 and 1 2, because in this case, this uh, actually In this case, 3 is still contributing to the answer, but you might have some uh, partitioning like 5, 3, 2, and 1. In this kind of an partitioning, you would have the contribution of 5, 2, and 1 will contribute twice. So you won't be able to have the contribution of 3, right? So in a nutshell, what I want to say is, whatever two partitions you had, it doesn't matter in which partition you put the max guy. Let's place it in the first partition. It doesn't matter in which partition you put up the minimum guy, it will always be the minimum. So let's say we did put up it in the uh, first set again, it doesn't matter. Then for the second largest guy, since you want to maximize the score and you have already placed the maximum guy, you would now think about the second maximum guy, है ना? Because that is the next big thing now. So if you place the second maximum guy, let's call this thing as max 2. If you place it here, then it won't really have any contribution to the answer. The maximum of set 2, whatever the value is, let's call it as x. We know that max 2 is the second largest guy. So x would always be less than equal to max 2. So obviously it is better to just place max 2 in the second set, basically in the other set. In whichever set you place max, place it in the opposite set of that. And now, talking about the second smallest guy, as we had talked about the smallest, and since we have placed the second maximum guy in the other set, you will naturally try to think of where should I place the second smallest guy. So maybe you got this in mind that, hey, if the second smallest guy is known as min2, let's place it here. Does it look good? Guys, yes or no? Does it look good? If yes, then why? If no, then why? Okay, it looks good. Great. But there is one issue. The the score had four factors. The minimum and the maximum of S1 and S2. Hana, the same thing for S2 as well, the minimum and maximum. You know that max guy would have come up as the maximum anyways. So this is fixed. This is also fixed as max and min. For max of S2, you have placed as this guy, max 2. But for this guy, if you had not placed this min2 here and you had placed it here, and in that case, whatever the minimum guy you would have for S2, it would have been larger than min2 for sure, or at least as large as min2. So obviously placing min2 here is actually making your score smaller. है ना? Does it make sense now? Placing min2 here is actually making your uh, it is actually making stuff bad for you, right? So it is actually better to just place the smallest guy min2 in the set 1 as well, in whichever set you did put min. Similarly for min3, again you would like to put it in the same place wherever you had put min and min2, and you will keep on doing it as much as you can. But you can't really put up all the elements in set 1 because you want to make sure that the total numbers of elements in S2 should also be greater than equal to k. So we can actually make up some formula from here, or actually we can generalize this. We know that in the set 1 we will put up the maximum guy. In the set 2 we will put up the second maximum guy. In the set 1 we are putting up the minimum guy, the second minimum guy, the third minimum guy, and so on, as many elements as we can, the smallest elements which we can. So eventually, this is one element that you pulled, which you pushed up here, and you would have uh, pushed up or inserted a lot of more small elements, so that there are exactly k elements here, and these k are actually the k largest elements other than the max k. So it will have max 2, max 3, and so on till max of k plus 1, right? This is nothing but having the k largest elements other than this guy. So the smallest element of the second set should actually be equal to max of k plus 1. Basically, the k plus 1th largest element. You know? So our score in this case is nothing but, we can say that the score would always be equal to the maximum plus minimum guy plus the second max guy plus में the k plus 1th max guy. Now you uh, will obviously doubt it. You will doubt that what is the guarantee that this will always give me the best answer, give me the best answer. So you can always try to think of some other ways that if you try to make any changes in this arrangement, maybe you would think about like having the size of this set. Yes, obviously you need to have it as at least greater than equal to k. So you can't remove any elements, you can only add more elements. And if you add any element from these smallest elements, then in that case, the smallest element of set 2 would be smaller than max of k plus 1, which will make the answer worse, right? If you try to um insert any of these elements into this set, then the size will become k minus 1 or smaller than that. So you will have to push some element here, which will again make the answer worse. One thing which you can try is putting up this max guy here and max 2 guy here. It won't make any change because uh, the maximum guy of set 1 will become max 2 and the maximum guy of set s2 will become max. So it will also work. But again, it will not have any better solution. So you can try to have a better rearrangement, but you won't be able to make it. So this is gonna be the best solution for us. I hope this is actually max of k plus 1. Yep, it should be max of k plus 1. But there is one edge case in our approach, and that is if this k was equal to 1, then in our solution, we would actually place, like let's say if k was equal to 1, then in our approach, we would have placed the max guy and then all the small elements here. And in S2, you would have placed only max 2 because you were trying to pick up only the k largest guys other than max. है ना? So in this case, the score will be equal to max plus min plus max 2 plus max 2. For set 2, max 2 is the smallest and the largest guy. है ना? Guys, try to identify where is the problem. Try to identify this. Like what could be a better arrangement in this case for us? Somebody is asking, is balanced uh, difficulties and count triplets discussed? No, I think this is gonna be the next problem after this current one. Try to identify what is the problem here. Exactly. WS came up with the like is able to spot the problem. here our score is this max plus min plus max 2 plus max 2. This max 2 is contributing twice to the solution. So if instead of having max in set 1 and max 2 in set 2, if we had max 2 here and max here, then in that case, we would have got max 2 plus min plus max as the solution, which would have definitely been at least as much as the current score, and it could even be greater than the current score, right? है ना? So for k equal to 1, our solution is gonna be equal to max plus max 2 plus min. And if you have k being greater than equal to 2, in that case you can see that you must place at least one guy here. So in that case it doesn't matter whether you have max coming up here or here. In that case everything is the exact same. So we can just say that if k is equal to 1, then this is our answer. If k is greater than 1, then this is our answer, है ना? So for finding out the value of max of k plus 1, there are multiple ways for doing it. The simplest way, in my opinion, is just sort the array. And then the k plus 1th largest guy is gonna be nothing but n minus k minus 1. Sorry, there's gonna be a of n minus k minus 1. After sorting the array in the ascending order, max guy will be nothing but a of n minus 1. Right now we are using zero based indexing. The second largest guy will be a of n minus 2, and the smallest guy will be a of 0. And obviously for finding the k plus 1 and largest guy, you can use heap as well. You can use priority queue approach if you like. You can go up with some other approaches as well. But the simplest one is just sort the array. That's it. There is no issue. So are we good to go? Should we move on to the code part? Or does anybody have any doubt? Okay, nice. So let's move on to the code. In my code, okay, so this is a bit different. The code this time is a bit different from the codes which you have seen till now in this session. This is actually my template in which I'm having some if else for debug, and I basically create a function with name solve, inside which I write the logic for solving each and every test case, and then I call the solve function for every test case. So you don't really need to worry about anything else like this part or any other part. Just look at this code. This is the main logic. First of all, I'm taking all the inputs, then I'm sorting the array, and after that, I'm creating an answer variable with value initially 0. Then this is the largest guy. This is the second largest guy, which I know that would always come. है ना? You know that the maximum, minimum, and the second maximum guys are always coming up in this code. So I added all of these first. After that, if k is equal to 1, then I'm adding the largest guy, otherwise the k plus 1th largest guy in my answer, and then I'm just printing my answer. That's it. The codes for all the solutions are very simple, other than the last problem which we will discuss. So I hope this is clear, and let's have a 2-minute break. till then you can grasp it, or maybe a 1 minute break. So 1 minute break. Where's the stopwatch? Okay. Okay, so hello guys, I'm audible. Hi, I'm audible. Sorry, there is some internet issue going on. Suddenly, my mobile network stopped working. I have connected to a different network now. Okay, so let me share the screen. Yep. So is my screen visible? Just 1 second. Okay, nice. So we had discussed till this problem, and now the next problem which we have to discuss is count triplets. So just 1 minute. Yeah. Okay. So let's discuss the problem count triplets. The problem says that we have been given an array of size n, and the values of this array will be in the range from 1 to 100. And we have to compute the number of triplets I, j, k satisfying the following condition. I, j, and k should be in the range from 1 to n. And there is some equation being given to us. Absolute difference of ai and ak should be equal to absolute difference of I and j and absolute difference of j and k. And the value of n can be pretty huge, but the value of ai will be pretty small. So first of all, the problem is, wait, 1 second. It's come up. Okay, so the problem is saying that we have been given an array. We have been given an array of length n, and we have to count the number of triplets I, j, k such that the absolute difference of ai and ak should be equal to the absolute difference of I and j plus absolute difference of j and k. This is the equation, and we want to find out all the triplets which satisfy this. The value of n can be pretty huge. It can be as big as 5 into 10 raised to the power 5, I think. Okay, sorry, 2 into 10 raised to the power 5. है ना? And the value of ai would be as big as 100. So this is something normal, but this is not a normal thing. It is already giving us a hint that maybe we will have some optimization by using this knowledge. As a matter of fact, the very straightforward observation is that if these values would be smaller than 100, then the absolute difference should also be less than 100. Now, the absolute difference of ai and ak for any values of I and k should obviously be always less than 100, or actually less than equal to 99. है ना? Uh, okay, again there is some pop-up. Fortunately, the recording is still going on. Okay, so we know this thing, that this must always hold true. This is already giving us a big hint that the absolute differences between I and j, or the absolute differences between j and k, cannot be too huge. Otherwise, the absolute difference of them would sum up to be something greater than 99, and this thing can never be equal to that. Okay, somebody is asking that why is the absolute difference always less than equal to 99 and not 100? See, the minimum possible value of any of the AI can be 1, and the maximum possible value any of them can have is 100. है ना? So even if this is the case, then the absolute difference is 99 only, and you cannot have a bigger absolute difference between any two AI and AK. Understood? Nice. Okay, so we have understood one thing, that the absolute difference will be less than equal to 99. This is the very first observation, the trivial one. And there is this equation, absolute difference of ij and absolute difference of j and k. Do you see something special? Like I and k are sort of symmetrical to each other. है ना? They are having absolute difference with each other. They are having absolute difference with j, and then that is being summed up. But in case of j, it is completely different from I and k. It is not even included in the LHS, and even in the RHS, it is coming up differently from the other two. So it is already giving us a hint that in whatever approach I think of, I can, let's say, maybe think about fixing up the values of I and k. Let's say if you have fixed I and k, then think about the value of j, something like that. है ना? We are already getting some hint. Even if you're not feeling it, even if you're not getting this hint by yourself, it is fine. We will come up to it later. But for now, you should have a question in your mind, that why is j different from both I and k? I and k are having some similar contribution in the expression, while j is having something different. Nextly, what is this expression meaning? Let's try to figure it out. I minus j plus j minus k. If you think about these integers I, j, and k on a number line, where uh, being on the right hand side on the number line means that the number is big, and being on the left side means that the number is small. So let's say I is less than k for now. Then there can be three possible places where j can lie. Either j will be smaller than I and k, or it would be greater than equal to I and less than equal to k, or it would be greater than k. है ना? If j is coming up between I and k, then this absolute difference of I and j means this thing from here till here. है ना? The absolute difference of I and j will be nothing but this length, and the absolute difference between j and k will be nothing but this length, right? So the sum of both of these is nothing but this length, which is nothing but the absolute difference between I and k. है ना? Does it make sense? I think this is something common. It Like having this kind of observation can simplify a lot of problems. So if you saw this for the very first time, um, try to just uh, think about it more and more until it looks intuitive to you, because it might actually help you to solve some problem in future fast, and it might help you to improve your rating fast. So If j is greater than equal to I and less than equal to k, in that case, uh, this expression is nothing but equal to absolute difference of I and k. Basically, the this will happen if j is less than equal to maximum of I and k, and j is greater than equal to minimum of I and k, right? And if j is less than I, है ना, if let's say j is coming up something like at a place like this, then I minus j is only this amount, and j minus k is this amount, right? So you are still covering this whole part, that is I minus k mod, and you're covering this area twice, that is nothing but j's difference with I, है ना? Or in reality, it is the difference of j with the minimum guy. So in this case, the difference is I minus k mod plus 2 into j's difference with I. Let's call this as diff for now. And if j was lying at some place like this, then this expression would have been this value plus this value, which is having this I minus k once, and this thing is coming up twice, that is, let's say 2 into diff. So basically, if j lies in this case, then I minus k is the case. Otherwise, um, otherwise, the expression can be said as I minus k plus 2 into diff, whereas this diff is the distance of j to the closer point, है ना? Distance of j to the closer point. So we have just figured out a better way of writing this expression. Like, this one looks simpler, but this one is actually giving us more information. Now, how can we use this information? Uh, let's say if you had some fixed values of I and k, then you know on the LHS you will definitely have just AI minus AK, absolute value of AI minus AK. So your LHS is having some fixed value, some constant value when you have I and K being fixed. On the right hand side, you will either have this expression or this expression, है ना? Or we can actually write this expression as I minus K plus 2 into D, where D will be equal to 0 if j is following, basically if j is between I and k, and j will be equal to, sorry, d will be equal to the distance to the closer point in case if j is outside these 2 points, है ना? You can maybe think about writing the equation like this as well. uh, so on the right hand side, you are having something like I minus k plus 2 into d. Now you can call it like this. This value is also fixed if you have fixed I and k. So in that way, you will just find out some value for d. 2 into d should be equal to the absolute difference between, sorry, not absolute difference, but absolute difference of ai and ak minus absolute difference of I and k. है ना? This is gonna be some constant value. This is gonna be some constant value. So you know about this constant value. This 2 is constant. So can you figure out the value of d? Can I say that you will actually be able to figure out the value of d, a concrete value, constant value? है ना? we can find out the value of d. Now, what is this d representing? This d was actually representing the distance of j from the 2 points. है ना? This d was greater than 0 on the left or the right side, and it was equal to 0 uh, for all the j where j was in the range from I to k. Right. And d is always an integer because I and j and k, all these are integers. And this d is then gonna be a difference between two integers only. So you know one thing for sure, d is always positive. Like it should always be positive. D should be positive and d should be an integer. Right. Or in simple words, d should be a whole number. So whatever value of d you got, if that d is less than 0, you can straight away say that for the particular combination of I and k, there is no possible value of j for which this equation will be true. If you got a value of d which is not an integer, maybe you got something like um, this value being odd, and then odd by 2 coming up to be something like 5.5 or 7.5, है ना? Basically you're getting some decimal value, then again you can say that there is no possible value of d for, possible value of j for which you have a triplet when I and k are fixed. So if the last possible case where d is a positive integer, or you can say it is a whole number, in that case there will be two possible values of j, है ना? You can easily figure it out. You can just say that j should either be equal to the minimum of I comma j, I comma k minus d, or j should either be equal to the minimum of I comma k, sorry, maximum of I comma k plus d. So you can just check if this value is greater than equal to 0. In that case, this would be a valid value for j because j is at an index, है ना? J is actually gonna work as an index, or we know that j must be coming up in the range of the indices from 0 to n-1 and 0 based indexing. So with the help of d, you will be able to find out some possible values for j, basically two possible values for j on the number line. Either j will be like here or here. So you will just say that this j should be greater than equal to 0 and this should be less than n. If this thing is greater than equal to 0, then this ijk is a good triplet. And if this is less than n, then this is also a good triplet. And if the value of d was 0, then all these possible values of j would be good. So for d equal to 0, you would have incremented answer by absolute difference of I minus k plus 1. है ना? So guys, does it make sense? Let's recap the whole problem once so that everything is in a proper order. The problem gave us an array A of size n. We had to figure out the number of triplets I, j, and k which satisfied a particular equation. The equation was absolute difference of ai and ak equal to absolute difference of I and j plus absolute difference of j and k. है ना? So we know that uh, these I and k were actually looking similar, you know, because you see, absolute difference of j and k is actually equivalent to saying absolute difference of k minus j. If you write it like this, then you can yourself see that I and k are actually very very similar, है ना? So you would try to think that if I just, let's say, fixed I and k, then in that case this LHS will have some constant value, है ना? Let's say if you are trying to find out the if you are trying to find out all the triplets where I is equal to 10 and k is equal to 6, so you just want to find out all the possible values of j for which uh, 10 j 6, this is a valid triplet. Now this is our problem. So you will try to find out this thing. Now this equation on the right hand side, or this expression on the right hand side, I minus j plus k minus j, we can visualize this on a graph where if you have minimum of I comma k here and the maximum of I comma k here, j can either be between them, or it can be smaller than the minimum guy, or it can be greater than the maximum guy. If this is in the middle, in that case this expression on the RHS would actually be this value plus this value, which is nothing but this value itself. So we will get I minus k, है ना? The absolute difference between I and k if j is in middle. If j is on the left hand side or on the right hand side, in that case uh, the expression, sorry, the expression would look like this, where this part is still coming up once and the distance of j with the closer point is having the distance being covered twice. So let's call this as d. This distance is d. So in that case, the value of j would be equal to, sorry, not the value of j, but the value of this right expression would be equal to I minus k plus 2 into d, है ना? So we can have our own expression, like we can just generalize this expression as I minus k plus 2 into let's call this as diff, the distance between j and the closest point is, let's say, diff. If this is called as diff, then the expression, uh, the whole expression, the right expression, can be called as I minus k plus 2 into d, where this d would be equal to 0 if j is lying in between both the points, and otherwise it will be equal to diff. Okay. So now all we have done, by the point behind manipulating this expression into something else, the whole reason was to decouple uh, these I, j, and j, k thing. Basically, we got I and k together, for which we would have uh, made them constant. है ना? We would have thought of I and k as constants. So this thing is actually now constant. This is already a constant. So your new equation, ai minus ak equal to I minus k plus 2 into d, has this thing as constant, this thing as constant. If you know about the value of I and k, let's say you are running two for loops for I and k, so you have fixed values of I and k again and again. So you would be able to get these constant values. This is also a constant. So in that way, you will be able to get some value for d. Now with the help of this value of d, you can just say if this d is less than 0, then that is actually an invalid case, है ना? the distance of j with the closest point can never be negative on either sides. So this d is less than 0 is actually indicating that you are not actually having any possible triplet where I and where you had those fixed values of I and k and you were searching for the possible values of j. Similarly, if d is not integer, and you know that d is nothing but the difference between j and the closest point, and the closest points, uh, these I and k values are integers, so it is indicating that j must not be an integer, but that is also not possible, so it also indicates that there are no combinations, no triplets. In the other case, if you got some value for d, let's say you got the value for d is 2, then in your number line where you had I equal to 10 and k equal to 6 now. So you had k equal to 6 here and I equal to 10. And let's say you got this d equal to 2. So it is indicating that j must either be 4 or j might either be 12. For both of these points, you would have got d equal to 2. So you can just verify that if these two values you are getting for j, are these valid? This will be valid if this j you have been getting on the left hand side is greater than equal to 0, and for the j you are getting on the right hand side, it should be less than n. There is a possibility that if let's say d was equal to 10, and here um, on the left hand side at a distance of 10, this j must have been equal to -4, so obviously that is also not a valid triplet. So you can just have these two checks. So these you have got these two triplets, 10 4 6, and similarly 10 12 6. है ना? Then there is the case where d could have been equal to 0. If d was equal to 0, um, then it means that this was this case where j is coming up in the middle. Now it doesn't matter where does j come. If j comes up here, then the distance between k and j and I and j will look like this, basically having this whole distance. Similarly, if j is here, then again the same thing will happen. So basically, all these points are valid for j. If j comes up at any of them, you will always have this as a valid triplet. So for j, the number of points where it can come between these 2 points is gonna be absolute difference of I and k plus 1. Basically the max guy minus min guy plus 1, which you can write as absolute difference plus 1. Right. So that's it. These are all the cases which we had to make. Now there's just one more thing. Can we really fix I and k? We did say that if we have fixed I and k, but can we really fix it? So here this information will come handy, that the absolute difference between these like on the left hand side can never be greater than 99, and on the right hand side you're always having this absolute difference between I and k. So you can just make sure that this thing is also always less than equal to 99. If this is greater than 99, then you know it for sure that the RHS would definitely be greater than LHS, so there is no possibility of having an equation. So what you can do is something like this. You can have a for loop of I starting from 0 till less than n, and then have a for loop for k starting from I minus 100 and going up till k less than equal to I plus 100. And Obviously, you need to make sure that k should always be greater than equal to 0 as well. If you cannot have a negative value of k, so you can maybe initialize k as maximum of 0 and uh, I minus 100. Similarly, k should always be less than equal to n minus 1. So you can have this equation as k should be less than equal to minimum of n minus 1 and I plus 100, or maybe I plus 99 as you wish. And inside that, you can have the conditions like finding out the value of d, and then on the basis of the value of d, you get figuring out the values, possible values of j. So, guys, does it make sense? Do you have any doubts on this problem? I think the explanation went a bit long because I explained the same thing twice, as I felt earlier that it might not be enough in the first go. Okay, nice. So let's move on to the code. In the code, first of all, I took all the inputs. Then I have these two for loops as we discussed here. Inside that, I'm having some conditions like uh, f- uh, this diff which I'm writing is not equal to the diff which we had discussed in the logic part. This is just a variable name I gave to this value, and uh, RD, the D which we were discussing in the logic part, is actually equal to diff by 2. So this is a little different from what we had discussed in the logic in this explanation. Basically, the logic is same, but the equations written are a bit different. Like we are checking if this diff is odd or not, instead of finding out the value of d and then checking if it is an integer or not, which is not gonna be that simple in coding. What we did is we found the value of 2 into d, and then we checked if it is odd or even. If it is odd, in that case d must be of decimal value. After that, we checked if diff is 0 or not, and if diff is not 0, in that case we are adding and subtracting diff by 2, because we had to add or subtract d, which is equal to diff by 2. And um, at the end, we are just printing answer. So how is it? Shall we move on to the next problem? Okay, very well. So now we have three problems left. Let's go a bit fast now, since these are harder problems. So now I can imagine that some more experienced people would be watching this part. So this is the problem, balance difficulties. This problem says that we have uh, an array A is considered, an array A of size n is considered to be balanced if for every AI it is greater than or equal to the previous element, and the difference between two consecutive elements is always less than equal to x. These are the two conditions for an array to be called as balanced. We have been given an array of length n, and we know that this array is sorted. This array is already sorted. but it might not follow the second condition of having these elements having absolute difference less than x. So what we can do is, in this array B, which we have, let's say B0, B1, B2, B3, and so on, Bn minus 1, we can add or subtract some value to them and make them, basically we can change their values. And let's say after changing the values, the array becomes equal to C0, C1, C2, C3, Cn minus 1. Then in that case, um, the cost will be known as, the cost will be calculated as maximum of Ci minus Bi for each I. So basically the absolute difference between these two, calculate absolute difference between these two and so on. And among all these absolute differences you got, pick up the maximum one, that is the cost of operations for now, right? We want to have this value as small as possible, and these new values which we pick up can be negative as well. It won't be a problem to pick up negative values for these elements. And our goal is that the new array C should be stable or whatever word they used for it. Uh, I don't know. Oh, yeah, balanced. They use the word balanced. So these new values, the new array C that is being created should be balanced. So guys, is the problem clear? Please write in chat yes or no. Okay, very well. So, so first of all, you will obviously try to think of of some greedy solution. You were being given the array B, B1, B2, B3, B4, and so on. Hello. And you created the array C0, C1, C2, C3, C4. So let's say that B1 and B2, sorry, B0 and B1 were having a difference of 10, and the value of x was equal to 5. Do you really know by how much should you increase the value of B0? By how much should you decrease the value of B1? In some cases, it might be better to just increase and decrease both their values by 5 and 5, and you might get the best solution. Or it might be better to increase this value by 10 and keep this value equal to 10. Like just don't change the value. Oh, sorry. You want to have the absolute difference between them to be less than equal to 5. So in some cases, it might be better to just increase the value of B0 by 5. In some cases, it might be better to just decrease the value of B1 by 5. In some cases, it might be better to increase some value of B0 and decrease some value of B1. है ना? Whatever operations you apply, um, by just looking at B0 and B1 and their absolute difference and the desired absolute difference, you can't really decide on how much should you decrease the value of something or increase the value, because eventually this B1 and B2, like if you change the value of B1, then the absolute difference between B1 and B2 would also differ. Similarly, when you change the value of B2, it changes with B3. In a nutshell, what I am trying to show you is, thinking about a greedy solution would be very, very difficult. In fact, it is not possible to greedily decide by just looking at B0 and B1 and their absolute differences. You can't really decide on by how much should you increase or decrease some value, because at the end of the day, the maximum, basically the cost will be equal to the maximum absolute difference between any BI and CI. है ना? This will be the cost at the end of the day. So let's say if you are changing the value of B2 by +10, then for B0, it doesn't matter if you increase it by +2 or +8 or +5 or even +7 or even +10. It doesn't matter. Even if you decrease its value by 10, it doesn't matter, because the cost will always be 10, because if you are changing these people, है ना, by 10. So as long as the absolute difference you are making here is less than 10, it won't change the cost. So this is giving us a hint that if we somehow fix this value, then maybe we can do something. Since if this value is being fixed, if you knew that this value is gonna be 10, then you can easily just increment B0 by 10, है ना? Or by any value up till 10 of your choice, just to make sure that B0 and B1 will not have their absolute difference being greater than 5. And since we want to find out this, uh, basically this is gonna be your cost, है ना? And you want to find out the minimum possible value of your cost, right? So this is giving us an intuition for binary search. If you have solved a lot of problems for binary search, this might be very intuitive for you. That as soon as you think about applying binary search on this cost, if you fix the value of the maximum difference you can make for any BI, in that case, now it would be easier for you to decide by how much should you increase the value of B0. Let me take one example. Let's say you have this case 2, 8, 10, 12. 2, 8, 10, 12, and x is equal to 1 here. है ना? So if you, let's say, decided that hey, I will try for cost equal to 5, or maybe let's say I will try for cost equal to, yeah, let's say 5. The absolute difference between these two is equal to 6 right now. So what is good? You can maybe increase this 2 and make it equal to 4, and that would also be fine, है ना? Or maybe just make it equal to 7. So the absolute difference between these two will be equal to 1, and everything is chill. Now for the next guy, 8. What can you do? You're having the absolute difference between 8 and this 10 as equal to 2. है ना? So to make this difference equal to less than equal to 1, either you can increase the value of 8, which you can't really do because the previous guy is equal to 7. So uh, if your current guy becomes greater than 8, then the absolute difference between these two will be messed up. So you can not increase this value by 8, and you will have to decrease this value by 1 and make it 9. Otherwise, the absolute difference between these two would be greater than equal to 1. Now, do you have some other choices as well? Yeah. You could have made this value equal to 9, or you could have made this value equal to even 8, or even 7. In all these cases, the absolute difference between these two would be less than equal to 1. So which value should I pick up? Which value should I pick up? Obviously the largest one now, the larger the current value is, the better the chance of the absolute difference between these two to be smaller. है ना? If you are having a 7 here, then the absolute difference between these two will be 5. Whereas if you pick up a 9 here, then the absolute difference between these two will be 3, which is smaller. So you will have a better chance of finding some combinations where you are able to create CI within the cost equal to 5. So in this case, you can just make this 12 equal to 10, and the absolute difference between these two will also be 1, and we will have the sequence 7, 8, 9, 10, which is really good. So this is just a dry run where we were trying to think of what we will do. I have not really told you about the actual approach which we will use. I was just trying to simulate in the way a person solving the problem with proven. So from here on, we can notice that if you're having some B0 and B1, then can I say it would always be it would always be the best decision. Yeah, for by the way, this, like, right now, let's say you are applying the binary search and you have some mid value for the cost of how much uh, differences you can make. So can I say that it would always be best for B0 to become equal to B0 plus mid? Can I say this? Yes or no? Obviously, I can say this because the larger value of B0 means it will become more closer to B0, sorry, B1. है ना? Does making B0 larger have any downsides? Obviously, no. One downside you might be able to think right now is, what if this value of mid is equal to 10 and B0 was equal to 4, B1 was equal to 6, and you just said that, hey, I will make the first guy equal to 14. Then this first guy would actually become quite larger than than this guy. But the thing is, you can add this much value to all the people, है ना? So even if your B0 is growing larger than the next guy, won't really cause any trouble. You can always just say that, hey, I will make B1 plus mid as well, so that B1 would also get closer to B2, है ना? In this way, you are actually having uh, if you are adding 10 to the current guy and making it so large, you are actually making it possible for the next guy to become as large as well. Uh, okay, so guys, please tell me in chat, is it looking intuitive or not? Did this thing look completely unintuitive, or did it look intuitive? Uh, Maybe you were not able to think about it on your own, but at least once I mentioned this, does it make sense that you can think about it on your own from the next time? Okay, so earlier it was unintuitive. Somebody said that this is like intuitive. Maybe I can take one example. The PCD might go a bit larger, but I think it will have better understanding. Let's say you had a case where the array B was 2, 5, and 20. And let's say x is equal to 3. And the value if mid is equal to 5. Or maybe not 5, but um, I think 6 is enough, no? Yep, 6. So for B0 and B1, both of these people are having their absolute difference as 3, which is actually less than equal to x in this case. So what looks as the intuitive thing to you? What is the most intuitive thing to you? In my case, I think for you the most intuitive thing might be just skip it. Everything is already fine, so why make any changes? You know, this might be looking intuitive to some people. So if you had thought like this, then in that case, in the CI array, in the array C, you just left the first value as 2 and the next value was 5. Now when you looked at these two people, the difference between them is 15, which is a lot larger than 3. So you need to make it larger. Sorry, you need to make either this guy larger or this guy smaller, or maybe do both of these. Now since you kept this value as 2 only, the maximum possible value you can have for this guy is only 5, है ना? Otherwise the absolute difference between these two will grow greater than 3. So you're not able to make this guy larger because you didn't make the previous guy larger. And for this guy, even if you make it smaller, how much smaller can you make it? You can make it 15, but that's not enough. Or maybe actually you can make it 14, but that is not enough, है ना? So you can see that we are having some problem because we thought that if things are looking fine, then why make any changes? In this kind of an example, it would have been better if you had thought about the future, that even if you don't need to make this guy very large right now, even if you don't need to make this guy very large right now, in future you might come across someone very large, and you might actually not have a lot of difference between them. It might be reachable. Like if you increment this by 6 and decrement this by 6, these people become 11 and 14, which are having the absolute difference is 3 only, which is good enough. Hannah, you might even have people like this, but since you didn't increase this guy, you might not be able to increase this guy. Hannah. So a better approach, thinking about the future from now itself, is that what is the maximum value I can give to the current guy? Because in the future, I will come across larger and larger people only. है ना? And I know that the next guy is always larger. So even if I become very large, even if this 2 becomes 8 after increasing plus 6, this 5 can also have plus 6 to become greater than the current guy. And you don't even need to always become a lot larger than the current guy. So basically, for this 5, there are two things. First of all, uh, the maximum possible value this 5 can obtain is either by adding the mid guy, and you don't want this 5 guy to become larger than 8 plus x, है ना? 8 plus 3 is 11. So you don't want this 5 to become greater than 11, and you can't even make it greater than 11 in this case. But overall, you got the idea that you would like to make 5 as large as possible so that the absolute difference between these two should be less than equal to x, and you have obtained the largest possible value for the current guy. Now in future, uh, for this 20, actually these values were coming from here. For this 20, what is the maximum possible value which this guy can get? If you add plus 6 to it, then it can reach 26. And for keeping the array balanced, the maximum possible value for this guy, the good maximum possible value for this guy is 11 plus 3, that is 14. So which like, you know that you can never have a value greater than 26 and you can never have a value greater than 14. So obviously this 14 is a bigger bottleneck, so you will have 14 as the value being chosen here. And in this case, all these three are having their absolute differences being less than equal to 3, right? So this is what I was trying to tell earlier. Um, but now I think in this way it would be more intuitive of what is the advantage of making these elements as large as possible, as in future you might come across someone very large and you might want to accomplish as large value as possible for this guy to be able to reach till the next guy, you know. So overall idea can be said as, for each I, um, the current guy, that is, let's say Ci, can be the minimum of uh, C of I minus 1 plus x, because if the current guy becomes greater than Ci minus 1 plus x, then the absolute difference between them will be greater than x. And the other thing is Bi plus mid. You can't really add more than mid to the current number. So whatever is the maximum one of them is the, sorry, minimum one of them is the value you will reach. And obviously there will be an if condition, that uh, if uh, the current guy if the current guy is too large than the previous one, such that even if you reduce mid from the current guy, it is still greater than Ci plus 1 plus x, then in that case, you see, for this cost, the answer is no. You cannot uh, make the array balanced. So you will just return false in this case. Yeah. Otherwise, we will return true. So this is how we can write our predicate function, which is like is possible for mid, where mid is this actually the cost which we are trying to achieve. Fine. So I think this is good enough. Now in this case, in this example, like when we tried for 5, we were able to achieve it. Earlier, we had looked at the example where we were able to achieve the answer for mid equal to 5, where this mid, or basically this cost, was equal to 5. Even if you had tried this thing for 4, you would have been able to achieve it. You could have made this 2 equal to 6 by incrementing 4, and made this 8 equal to 7 by decrementing 1, made this 10 equal to 8, and this 12 equal to 9, so that the absolute difference between any two of them will be equal to 1. So let's look at the code. In the code, first I took the inputs as usual, and in the binary search, like this is the binary search code, I have set the start and the end ranges as 0 and 1e9. The reason is your cost, um, your cost can never be negative, है ना? Your cost would always be greater than equal to 0. 0 in the case if uh, the array is already balanced, and 1 in n is a very big value. So let's say if you talk about uh, cost equal to 29, then this is the case where you will be actually able to make all the values of array, since all the values of array are in the range from 1 to 29. If you can change the values of the array by even this much, then you can make all the elements just equal to 1 or 0, basically the same value, है ना? So for any possible value of x, you would definitely be able to make the array balanced. So in a nutshell, for the cost 1e9, you are gonna be able to make the array balanced for sure, and your answer will always lie in the range from 0 to 29, somewhere in between, है ना? The cost is basically the smallest value where you can make the array balanced, with which actually the smallest cost with which you can make the array balanced. So this is good enough, I think. And the condition, yeah, this is the binary search code. This is not complicated, this is simple. I'm just saying that, hey, if this check function will return me true if I can make the array balanced. So if I can make the array balanced, then store the value of m in this variable within this, which is a short form of result, and make the value of e smaller. Try to find out a smaller value for which you get true. And yeah, and in the checker function, we are just doing the exact same thing as we had discussed in the logic part during the explanation. And after finding out the best possible value of risk, we have been doing it once again to find out all the basically find out the new RSCI, where we will just do this exact same step which we were discussing during the logic part, and we will be able to get this answer array, and then we can just print it. So does it make sense on how we are coding it? I think the code part is not that complicated, especially for some people who are coming up at this problem. So if anybody has any doubt, then please ask. Otherwise, we can move on to the next problem. This PCD went up a bit longer because we literally had a lot of problems to discuss. Okay, so the next problem is interval clicks. This problem says that we have been given n intervals. An interval ij equal to lj comma rj means that it contains all the real numbers between lj and rj. So let's remove this. If you have been like in the problem, you have been given an array of intervals of size n, where ij is actually representing a 2D array of, or actually a pair of, maybe let's write it like this. uh, ij represents an array of two size lj comma rj, which represents that this interval will have all the real numbers in the range from lj to rj. And we have been told that all these 2 into n endpoints, basically there are n intervals, each interval is having two endpoints, lj and rj. So all these 2 into n endpoints are unique. ठीक है. And we have to construct a graph of n nodes such that there is an edge between nodes x and y if and only if these two conditions are both satisfied. There is at least one real number contained in ix but not in iy, and there is at least one real number contained in iy and in not in ix. So first of all, let's see. If you have two intervals, let's say the first interval is this, then the second interval might be like this, starting late and ending late. Or there can be a case like this where the second interval is starting early and ending early. Or you might have a case where the second interval is starting late and ending early. Or you might have a case where the second interval is containing the current interval completely. है ना? These are the only four possible cases for two intervals. Actually, there is one more case. There are two more cases, like two intervals having nothing in common, and two intervals having nothing in common in this way as well. है ना? So in the first case, there is something in red interval which is not in blue, and similarly there is something in blue which is not in red. Here as well, there is something in blue which is not in red, and vice versa. In this case, there is nothing which is in blue but not in red. There is something in red not in blue, but the other way around is not true. Similarly, in this as well, there is nothing in red which is not in blue. Here in this case, both of them are having a lot of things which are not in the other one. Here as well. है ना? So in the graph, we will have an edge between these two, these two, these two, these two, but not in this case. है ना? Basically, we just tried to make the problem simple for us. Now we know which nodes will have edges between them and which ones will not. So if you have two intervals such that Li is less than Lj and Ri is less than Rj, or the other way around, where Li is greater than Lj with Ri being greater than Rj, in like if either of these is happening, then you will have an edge between interval I and interval j. है ना? We have to find out the maximum size of a click in this constructed graph. So in this graph, which contains n nodes, a lot of nodes might be connected with a lot of other nodes, है ना? Because of this condition. Like this condition might be true for all of nodes. Let me give an example. If you had Li equal to Ri equal to I for each I, for each interval I, if you had values like this, in that case, um, all the nodes will be connected with each other. This will be a connected graph in that case. So there can be basically a lot of edges in the given problem. In the problem, we have a lot of nodes, है ना? And this can form a connected graph as well. So the number of edges can actually go up as large as something like in order of n square. Okay. So this is giving us a hint that we won't really have to create an actual graph. Most likely we won't have to create an actual graph. Or even if we have to create an actual graph, then uh, all we can do is create some dummy nodes and connect the current nodes with those dummy nodes. But in this problem, we don't really have to do that. uh, with all the intuitions which we have got, we have realized one thing, that maybe try to solve the problem without actually creating a graph. We have to find out the maximum size of a click. Now, what is click? They have given up the link to uh, Wikipedia uh, page, which is telling what is a click. Let me tell you about that in brief. If you have, if you pick up some nodes in the graph, basically, if you pick up a subgraph of the current graph, and all these nodes are connected to each other, all of them are having edges connecting to each other. Basically, it is looking like a connected graph if you only consider these four nodes. This is considered a click in the graph, and the size of this click is equal to the number of nodes. So here in this case we have four nodes, so this size is 4. We have to find out the largest click, or basically the maximum size of any click, है ना? So can I say that in a click the if the intervals are like I1, I2, I3, I4, they will have some sort of relation, like if I1, like if L1 is less than L3, then R1 would also be less than R3. If let's say, like since all of these are connected, all of these will have this relation. So if I2 is I2 and I4, since I2 and I4 would be connected, if it is a click, then it means that if L2 is less than L4, then R2 would also be less than R4. If let's say L3 is greater than R4, sorry, L3 is greater than L4, then R3 must also be greater than R4. है ना? You will have these relationships, that if this is true, then this must be true. If this is true, then this must be true. If this is true, then this must be true. Since they must have an edge with them. Yeah, one more thing. Along with this, there could be some special cases. A special case could have been like this as well, like one interval like this and the second interval starting from here itself, but ending at ending a little later. So it is actually completely containing the red interval. This blue interval is completely containing the red interval, which is a case similar to this, है ना? But in this case, there is no inequality. It is act Yeah, this is an inequality, but here L L1 and L2 are actually equal. But in our problem, in the current problem, this thing cannot happen because we have been told that these two endpoints are distinct. These are distinct. So this is why the problem has got a little simple. Otherwise, these cases could have been a bit complicated to handle. Now we know one thing for sure, that for whatever is the final answer, they must have these relations. So let us say, if for all the intervals which I had been given initially, if I sorted them on the basis of their L values, on the basis of their Li, let me take one example. We have these inputs 192437, 192437, 5, 6, and 8, 10, 5, 6, and 8, 10. And if I just sort them on the basis of their L values, currently they are already sorted, then uh, I know that since all these L are already unique, है ना? All these L values are already unique and I have now, let's say, sorted them. So I can just uh, consider their R values now. Maybe let's store their R values in some other array, because I don't really care about the exact values of these L values. I only cared about their relation with each other. है ना? Like the L value of this guy is smaller than this. I only cared about this thing. So now all these pairs where the value coming up on the left is smaller than the value coming up on the right, they will have an edge with each other. है ना? I have simplified the problem now. So now I just have to find out the largest subsequence where the consecutive elements are basically the largest subsequence which is sorted. Or you can say in simple words, now the problem can be said as find out the longest increasing subsequence. है ना? Because if you find out the longest increasing subsequence, every increasing subsequence must be a click for sure. First of all, this thing is always true. If you have um, these three um, people who are in sorted order, you know that their L values are already sorted. Now their R values are also sorted. So there is an edge between these two, there is an edge between these two, there is an edge between these two, and so on. So in a nutshell, all of these are forming a click. So all these increasing subsequence will form a click, and we want to find out the maximum click, maximum size of a click. So we actually care about the longest increasing subsequence, and not really the longest increasing subsequence, but actually the length of the normal increasing subsequence. And calculating this thing is simple. You can do it in n log n time complexity using binary search and sorting the array to get all the values such that their L values are sorted is also something which can be done in n log n by just using the simple sort function. You can create a new array. You can create a new oops. Yeah, you can create this. You can create a new. I think. Yeah, just 1 second. Sorry, I mistakenly clicked on stop share. Okay, so we could do this thing in big O of n log n time complexity. Creating this new array from this part can also be done in big O of n log n time complexity, and then calculating the LIS can also be done in n log n time complexity. Sorry, this can be done in big O of n. Yeah, this can be done in big O of n. And to be honest, you don't really need to create this new array. You can directly calculate the LIS on this array uh, by right by considering the second element in your logic, and just exclude the first element completely. Ignore the first elements completely. है ना? So guys, how is this problem now? Is it making sense? Is it clear or not? If you have any doubts, feel free to ask. Should I say guys or should I say guy? Okay, so uh, let's move on to the code part. This problem was actually simple in like considering the position of this problem. So I took the inputs first. After that, I sorted the array. Then I created a new array, and in that array, I just pushed all these second values, or basically these R values. After that, I calculated the length of this LIS. This is a standard thing. You can find multiple resources online as well. Like this code is taken from GFG, and you can just then print the answer. That's it. So let's move on to the last problem of the contest. Actually, not the last problem. The last second problem of the contest. I could not solve the last problem, so this will be the last problem to be discussed. The problem says that we are being given a tree. We are being given a tree, and in this tree, at every node, at each and every node, there is a magnet, and let's and we can perform one operation n times. Uh, we can perform one operation n times, basically one time on each node, one one time on each node. So we can apply this operation. Now in one operation, what will happen is, um, let's say you had a tree like this having four nodes. Um, this node was having a magnet. uh, yeah, this node was having a magnet, this node had a magnet, this node had a magnet, this node had a magnet. And in one operation, you will have to choose a node and you will place an external magnet at that place. Now, at all the nodes other than the current node, they will like the magnets on those nodes will come one step towards the external magnet. So after applying this operation, the new places for these magnets would be this and this. Okay. Let's say you applied one operation here, then in that case, these magnets will go towards that position, and your new graph will, or your new tree will become like this, having magnets here and here, and so on. And now you will have to apply exactly an operations, and in each operation you have to pick up a different node. Basically, you have to apply the operation for all nodes from one to one by one. You can apply these operations in any order. So now at the end of the day, what you want is that uh, the nodes which are having the magnets, like it should not happen like the case where all the nodes or all the magnets are at one node only. We want to avoid this case. So what do I mean by all the magnets at one node only? Let's say if I had applied an operation for this node, then these magnets would have been removed from here and they would have come up here. And then let's say I applied the operation for this node. Then in that case, these magnets will all come up to this node. है ना? So all the four magnets which I initially had, all of them are coming up at one node only. This is something we want to avoid. We want to give the sequence in which we will place the magnets one by one at the nodes, and after the operation we will remove those external magnets. And at the end of the day, we want the magnets to be present at different nodes, at least at two different nodes. So in this situation, if like what we could have done is we could have chosen this node first. So all these nodes would come up at this place. Then we could have chosen this node. So all these magnets will come up here. And yeah, one by one, we have chosen all the nodes. And here you can see that we are having two nodes having magnets. So all the magnets are not at the same place, which is a good thing. So I hope the problem is clear. The logic is a bit tricky, but not complicated. Uh, the thing is, let's start from the very basic. If there are only two nodes, obviously this is the only configuration, and it doesn't matter where you place the node. It doesn't matter where you place the uh, external magnet, you will fail. For n equal to 3, again you can try to place magnets. You have magnets at all the places right now. Let's say you chose this guy, so the new magnets will look like this, and you have chosen this guy. Let's say you chose this guy next, so these magnets will come up here, and you have chosen this guy as well. But eventually you will have to choose the middle guy, and whenever you choose the middle guy, you will have all the magnets at the same place, so you will fail, है ना? And for n equal to 4, this is one configuration, one possible configuration. This is another possible configuration. In this configuration as well, when you will try to put up the magnets, you will see that eventually, because of this node at the middle, um, eventually all the magnets will have to come up together. So this is also not going to happen. For n equal to 4, we have already seen how you can accomplish it. You have nodes. You have nodes like these. Maybe you placed an external magnet at this place. So all these magnets came close. Then you placed an external magnet here. So all these came here. Then you placed an external magnet at this place. So all these magnets came here. And then you place the external magnet here. So the magnets came up here, and you were able to place all these external magnets one by one, and you are not having all the magnets at the same place. This was the example. I just did it in the exact same way as they had done in the example. And one thing I noticed from there was, after the very first operation, these magnets had come up in this way. So now, if I choose any magnet in this tree, or even if the tree looked very, very complicated, it can be very complicated, it doesn't matter. As long as I don't choose one of these two magnets and choose any other node, these two magnets will go towards that node, and they would always stay adjacent. These two nodes will always stay adjacent. They won't um, come up at the same node. And this is a good thing for me. So I can just try to make sure that these two nodes always stay adjacent and they don't clash with each other. Never ever clash with each other. And as we saw that we just require 4 consecutive nodes. And now, if you have 4 consecutive nodes, you can just perform these 4 operations first. And now, in that way, you would have already applied operations on these 4 nodes. These would have already been done. And then you can apply operations on some other nodes. So if you have a graph in which you are having four consecutive nodes, how will you find four consecutive nodes? What I did was I just said that, hey, maybe just find the diameter. You don't really need to do this. You can start from any node and apply a DFS to find out any node at a distance of 4. But in my course, I had a template for diameter. So I just calculated the diameter of the given tree. Let's say this is the diameter. Um, so the given tree can look like this, where we are having, this is the diameter, you know, the longest path. I just checked whether this longest path has four more than four number of nodes or not. The only three trees with less than four number of nodes in the diameter are these three. And for all of these three, I'm getting the answer is -1. I can't uh, get any answer. So if the length of the diameter is less than 4, then I straight away say the answer is not possible. If the length is greater than 4 and I have found the path, like I will just maybe call a function with name getPath, which will give me the path from one of the nodes to the next node. So what I can do is I can pick up the first, second, third, and the fourth node in the diameter. The goal was just was to just find out four nodes uh, in a straight line. That's it. You just wanted to have four nodes. These four nodes could have been like this as well. It doesn't matter. These four nodes could have been these as well. It doesn't matter. Okay. Now, once you found out these four nodes, you can just apply these four initial operations, one on this, and this, so that you would have applied operations on these four nodes, which uh, like you have already placed external magnets on them one by one, and you are having these adjacent nodes, these adjacent magnets here. Okay. It doesn't matter in that complete tree, wherever you apply the like wherever you place the magnet. Now let's say place a magnet here, these will just go towards that and they will always stay adjacent, right? They are right now like this. Let's say I apply the operation here, so they will just move on towards the right and they will now come up here, and in the same way, right? Though there can still be some failure. Let's say I applied this operation, so my two nodes uh, came up from here and there, they reached here. I applied an operation here, so these two nodes came up here and here, they reached here. Then let's say I applied an operation here, so these two nodes would have come up here, sorry, basically the two magnets, and these magnets would reach here. Now can you see, you have not applied an operation on this till now. Let's say I apply an operation here, then these two will come up together. So in a nutshell, what I'm trying to tell you is that even if you came up till this part, even if you have thought your logic till this point, the problem is not done, because if you randomly put up the external magnets anywhere, then you can still have some trouble. So it would be better to place these magnets in some uh, good way, basically in a more reliable way. So one thing which I can definitely say is, from this note, uh, basically I know that these are the four nodes that have already where I have already placed the external magnet. Now if I place the next external magnet at one of their neighbors, then even if my magnets reach there, it is not having any problem, because for both of these nodes you would have already applied operations on them, so it is good for you, है ना? So every time whenever you have to decide a node where you will place the next external magnet, just pick up a node which is directly connected with any one of the nodes where you have already placed the external magnet. So you will never reach a situation where you have the external, where you have your magnets at two nodes and one of them, and at one of them you can apply an operation. You will never have this problem for you, है ना? So in my case, I just applied a DFS to find out all the nodes one by one, and every time I get a node, it would be a neighbor of one of the nodes which I have already visited. So this worked well for me. You can apply BFS as well. It's up to you. Apply DFS or BFS or any other search of your choice. It is fine. And I think this problem is actually a lot simpler for being the last second problem of the contest. In general, the last second problems are quite difficult. So that's it for this problem. I believe that this much explanation should be good enough for the ones who are watching till this point. Let me give you a glimpse of my code. So I had two templates, find diameter and get path. I created these templates earlier because these are two useful functions uh, which come in use a lot of times. And in my main function for solving the problem, first I'm taking all the inputs, creating a graph, basically creating a tree. After that, I calculated the diameter. I got the diameter. Then I found the path for the diameter. If the diameter size is less than 3, then just return -1 because there is no possible answer. If the diameter length is at least 4, then in that case, you can always get an answer. है ना? So for getting an answer, you want to place the magnet on all the nodes from 1 to n in any order, but you have to place uh, the external magnet at them one by one and at least once everywhere, exactly once everywhere. So that is why I created a set to keep track of all the nodes where I have to place the node in future as well. I inserted all the values from 1 to n, and I created an answer vector which I will print at the end. And I created a function with name place in which I will pass on the node number if that node has already been operated. If I have already placed external magnet there, then I will just return. Otherwise, I will push this into my answer and uh, insert, like erase this node from the set so that I would never place an external magnet there. And initially, I'm just placing the magnet at the first four nodes in the path. First at this place, this, then this, then this. So the indices are, uh, sorry, 0, 1, 2, 3. So the indices are first 2, then 3, then 1, then 0, 2, 3, 1, 0. And then for figuring out the nodes where I will have to place the external magnet, I'm applying a DFS. You can apply a BFS if you want. And at the end, you can ignore this. That was just a check that just in case if my answer length is not equal to n, then I will get an runtime error. So I will know, I will have a better idea of why my answer is failing. It just helps in debugging. And at this place, I'm just printing the answer. So that is it for this session. I hope you liked this video. We did discuss a lot of problems, and for most of them, we actually did discuss in a lot of detail. So if you did like the session, if you did feel that I did put up efforts continuously for 3 hours, then uh, please give a thumbs up. Thank you for watching the video, and bye bye.